Hi, this is Mrs. Bustamante. Today I want to talk about sex determination based on inheritance. Because a lot of times, most of the time we spend in genetics, we talk about non-sex chromosomes, right? We're talking about traits that would just be on what we call autosomal chromosomes. But we also know that there are, genetically speaking, males and females, right? And how does that get determined? Well, there are special sex chromosomes that you inherit from your parents, or offspring inherit from their parents, that determine if they're male or female. We call them their sex chromosomes. And we say that females receive 2 copies of an X chromosome. So we say that females are XX and males are XY. And you'll notice the only difference here is that males have a Y chromosome, and if you have that Y chromosome, we would say that your sex determination is that you're male, right? So, in order to reproduce, you have to have a male parent and a female parent, right? And the male would be XY and the female could be XX. And what I like to point out here is that the only option the female has to give to her offspring is an X chromosome. Males, however, can pass down either an X or a Y. So when we talk about the sex determination in offspring, really the male parent is determining if the offspring is male or female based on what gamete is fertilized. So here's our Punnett square. We do these just like we've been doing all our other Punnett squares. We put one parent on top, XY here, and the other parent on the side. And then we're going to fill in our Punnett square, right? XX across, XX across. Bring the first X down, bring my second X down, and then Y down, Y down. Okay, so let's look at these and think. This would give a female phenotype, male phenotype, male phenotype, right? So sometimes you'll hear that there's a 50-50 chance of being a boy or a girl. Well, this is really why, right? Because all the mother can give is an X. It's done. She always gives the same thing. But the father kind of can give either an X or a Y, which means there are only 2 options, and both of them are a 50% chance. Now, I think a lot of times this, more than any of them, is the one where people think, oh, well, the first child was a female, maybe they had another child, it was a female, and so the next one will be a male. And that's not how this works. Remember, every time there's a new offspring, this probability restarts, if you will, or takes place again. That's why every time parents have some sort of an offspring, there's a 50-50 chance that it will be male or female. And you can have families that are very, very big and maybe even have children all of one offspring just because of that rule.